Life is simple. Mathematics made it simpler. Welcome to the Mathlux. Today we are going to solve a question on kinematics, that's particles in motion. If you like to give this question a try, you can pause the video and keep watching when you are done. Let's start. A particle starts from rest and accelerates to a velocity of 5 meters per second in 20 seconds. It maintains this velocity for 10 seconds and then decelerates to rest in further 10 seconds. Draw a velocity time graph for the motion, and I calculate the initial acceleration of the particle and the total distance covered. So now let's start the solution. Let's tackle the I part of the question. So now the I says draw a velocity time graph of the motion. So now there is a velocity plotted against time. So now we draw a velocity time graph. Now this will be time in seconds, and this will be velocity meters per second. So now it says that a particle starts from rest. Now when a particle starts from rest, it starts from the point 0 here. So now it starts from rest and accelerates to a velocity of 5 meters per second. So it accelerates to a velocity of 5 meters per second. So if this is 5 meters per second, 5. So now it's in 20 seconds, meaning that the time taken to move from 0 rest to the velocity of 5 seconds is 20 seconds. So it's 20 seconds. That the time taken to reach a velocity of 5 meters per second is 20 seconds. Now, and it's what does it say? It maintains this velocity for 10 seconds. So it maintains this velocity for 10 seconds. Making adding 10 to 20 seconds, we get 30. Let's remove this here. Now, and it says, and then decelerates to rest in further 10 seconds. So it decelerates to rest. Like this. Okay, like this. So then the time will be 40 seconds. Adding 10 seconds, so it makes it 40 seconds. So now we've drawn our velocity time graph for the motion. So now let's continue to the second part of the question, the I part. Now the I part is calculate the initial acceleration of the particle and total distance covered. So now let's start. Now initial acceleration of the particle. So now this will be it. We'll use here to solve for it. Now let's see, from the three equations of motion, v is equal to u plus at, s is equal to ut plus half gen at squared, and v squared is equal to u squared plus 2 gen s. Now looking at these three equations, we know that when given the distance covered, so now we will not use these Newton's equations to solve it, but rather we'll use, the formula for acceleration at the rate of change of velocity with time. So we'll use that one down. Acceleration is equal to what? The change in velocity, that's the final velocity, minus the initial velocity over the time taken to make that change. So now the acceleration will be equal to, the final velocity was 5, and the initial velocity, since it was from rest, is 0. Then the time it took to move from that place, we can see, is 20 seconds. So now we get the acceleration to be 5 on 20. Then dividing it, we'll get the acceleration to be 0.25 meters per second squared. 0.25 meters per second squared. Sorry that you didn't see it. So now let's continue. Now the question also asks that we solve. So now the question also asks that we solve for the total distance covered. So now the distance covered is the portion under here, beneath the graph here. So now let's divide it like this. Now the portion here is the total distance covered. So now we will solve for that portion. So now in solving for that portion, we isolate the shapes. So here you have a triangle and you have a rectangle here, we have another triangle here. So we isolate and solve for the areas of those shapes, then we add it, then we get the total distance covered. So now let's solve for, I label here this first part, this plus at area 1, area 2, and what, area 3. So now we solve for area 1. That's area 1. So now looking at area 1, we get the height to be 5. The height to be 5. Since the area of a triangle is half times the base times the height. So we hit half times the base. The base is 20. The base here is 20. So 20 times the height, 5. Then we get here to be what? 5, 10. Then we get it to be 50. So we get it to be 50 meters squared because it's area. Now for area 2, we have a rectangle which is length times breadth. Area for a rectangle. Then we get that the height is still 5, and the base here, the length times the breadth. So if this is the length and this is the breadth, the length will be 5 and the breadth will be 10. So it will be what? 5 times 10. Then we get here to be what? 50 meters squared. Then for area 3, we have another triangle which gives half times base times height. Then we get half multiplying the base. The base is 10. The base is 10 and the height is 5. So we get 25 meters squared. So now adding these three, we get the total distance covered. So now adding 50 and 25 here, we get a total distance covered to be 125 meters. We exclude the square. So now this will be the total distance covered. And remember, the total distance covered is always the area under the graph here. So now it's simple. Like the video, subscribe to the channel, and don't forget that this is Mathlux. Thank you.